Hi everyone, today I want to start chapter 6, which talks about arithmetic and move instructions. At first I'll start with arithmetic instruction and then I will teach you move instruction and how you can use them in different applications. In Allen Bradley's PLC, we have access to a bunch of arithmetic instructions, which are useful for developing programs for different applications. Here in this table, you can see their names and a brief description of what they do and what are their parameters. I will describe some of them here, and I will tell you that how we can set the parameters, how we are going to use them in our program. So those we are going to discuss about some of them that we are going to work with them more frequently. So here is the first part of the table, and then we have this one, which is the rest of them. Some of them, the name tells you what exactly they're doing. For example, arc sine, arc cosine, or natural log. So they're clear as long as you know that you have access to these arithmetic instruction in your PLC. Then whenever you need them in your application, you can study them and work with them in your program. Okay, let's look at the structure of some arithmetic instruction. Here we have add instruction, clear instruction, and a square root instruction. Okay, so what you can see in common between them, you have parameters like source and destination. What is the source? The source is the address of the value which the mathematical operation is to be performed, and then we have destination, and the destination is the address where the result of the operation will be stored. So you have these two parameters in your arithmetic instruction. In some of them you have two operand or two source. In some of them you have only one. In some of them you don't have any operand. So here the first one you have two source A and source B, and that's clear because when you're adding, basically you need to have number A and then number B, so then you can add them together. So for add instruction you have two operand or two source. For clear, you don't need to have any operand, you only need to have the destination to save the value and basically clear the value. So there is no operand or source in clear instruction, and then in SQR you only need one source, and then the operation can be performed on the data from your source, and it will be square root. The square root will be applied, and then you are going to save your number in your destination. So as you can see, in all of them you need to have one destination in which you can save the result of your operation, but the source depends on your instruction type. So if it's adding or subtracting or multiplying or dividing, then you need to describe two parameters as your source A and source B. If for something like absolute value, SQRT, something like this, you only need one source, and for some of them you don't need to have any source, you only need to have the destination. And an example for that is the clear instruction. Okay, let's look at addition instruction here. So we want to see how the add instruction works. If you use add instruction in your PLC, in your program, this is the box that you will see, and you need to set your parameters. The add instruction will perform the addition of two operand, which are source A and source B, and then you have the data here, and then the result will be stored in another memory location. Now these sources, they might be a constant number or a variable. So you can enter, for example, for source A, you can just say enter 15. Here source B is 15. So it can be a constant number, or it can refer to a location in the memory. So you can enter a constant number as your source, just type the number, or you can use part of memory and address to that memory location. Now how the addressing works, if you remember we have different file type. So the first file was output, which was 0. Then we have input, which was 1, file 1. Then we had bit file, a status file, which was 2. Then bit file as 3, timer as 4, counter as 5. Now, if you go forward, file number 7 is integer file. So in file number 7, you can store variable integer numbers. So here you can see it is addressing to N7. So it means that in N7, which is your integer file, you can save any integer number. So the first block is basically your N70. The second block is N71, and here it's referring to this block. So the integer value which is stored at this particular location in memory. So as you can see, you can use a constant value and enter your value as your source value, or you can refer to a place in your memory and provide the address for the instruction. So here we are providing the address for the instruction. And then in your destination, you need to have an address to save the information. So for the destination, you definitely need to provide an address. Here, the address is N7:3, which means the next block is going to be N72. The next one after that is going to be N73. So whatever you have here will be stored, will be added to 15, and then the result will be stored in N73. So this is what's happening here. Now remember that because we have a condition here, then this addition will happen if we have continuity over this input. So if input terminal 0 is true, then the addition will happen. Now let's look at another addition instruction. Let's see how we can use this in other form. Still we have the similar condition. So this time we are looking at input terminal 1. If the input terminal 1 brings continuity and it's true, then the addition happens. Now what we are doing here, in this one, I'm going to use another color. In this one, we are adding the accumulator value of counter 1. So C5:1 refers to counter 1, and then .acc refers to the accumulator value. So we are adding the accumulator value of counter 1 to the integer value at N7:4. So this is our N7:4. So we are adding, let me delete here, okay. So we are adding this accumulator value, which is C5:1.acc to N7:4. So the integer number that we have at N7:4 will be added to the accumulator value of counter 1, and the result will be saved and stored as the preset value of timer 3. That's a very interesting application. So you are adding an integer value from your integer file here, and then this integer file is added to your counter accumulator value, the accumulator value of counter 1, and then the result of addition is stored as the preset of timer 3. So this way you can change your timer preset in your program by using arithmetic instruction. Now in this slide, you can see subtraction instruction. So SUB stands for subtraction. And let's see what this instruction is doing here. In this instruction, our source has an address to integer file. The next source B has also address to integer file, and destination is also addressing to integer file. So if I draw integer file, which is N7 file, then it means that this particular instruction, if the input wrong is true, if terminal 0 of input is true, then source A, which is N7-1, this is my source A, N7:1, will be added to N7:2, N7:2. So this is my source A, this is my source B, and my destination is N7:3. So the result of adding these two will be stored in N7:3. The next slide shows you the same procedure for multiplication and division instruction. So this time, if I use MUL, which stands for multiplication, instead of adding, or instead of subtracting, sorry, in previous slide, I was subtracting. So let me correct it here. So here they will be subtracted, and then the result will be saved here. So here, the value in source B will be subtracted from the value in source A, and the result will be stored in destination. So here, for example, if you have 25 in your N7-2 and 45 here, after having a true statement here, what you will have in N7-3 will be 20. So source B will be subtracted from source A. Now, similar thing happens here in next slide when we have multiplication or division. So whenever your input wrong is true, then the multiplication will happen. Your source A will be multiplied by source B, and the result will be saved in destination, and similar for division. Okay, the next slide, we have a square root instruction, or SQR instruction. As we already talked about it, here you have only one source, and that's N7-1 in this case. Now, this particular instruction will provide the square root of the address you provide as your source, and it will be stored in your destination. Now, something that you should be careful is that if the value you're providing as your source is negative, then what will happen is that the absolute value will be used, and the operation will be performed on the absolute value. So the square root of the absolute value will be saved at your destination.